My name is Dr. Matt Rasband. I'm a professor of neuroscience at Baylor College of Medicine. I'd like to invite you, our prospective graduate student, to learn more about sensory systems neuroscience from my colleague, Dr. Matt McGinley.
What's most amazing about Baylor is that it's both highly collaborative and high-powered science. So I think you find a lot of places tend to be one or the other, and I think at Baylor you really get both. The neuroscience program prepares students to study sensory systems in a number of ways, primarily through the coursework. We introduce all of the major sensory systems, somatosensory, auditory, vestibular, visual of course, and introduce them also at a full range of levels, from molecular all the way to human perception. In addition, through laboratory rotations and the large number of labs that work on sensory systems, there are many opportunities to dive into any system at any level. Mirroring the range of levels that we study sensory systems at Baylor, there are many questions in all the way from the molecular level to the behavioral level. So for example, Fabrizio Gabbiani, one of our faculty, studies vision in locusts. So it's a very simple organism, but that allows him to hopefully really get a fairly complete understanding of how visual information is processed, all the way down at the level of single neurons and their dendrites. Whereas some of our faculty that work in humans, like Jeff Yao, Brett Foster, study human vision in the context of memory or in the context of multisensory integration. And there they have much less direct readouts, more macro level functional magnetic imaging. But of course, what's really exciting is we're looking at the human brain. One exciting aspect of the study of sensory systems at Baylor is that we have faculty working at the interface of artificial intelligence and machine perception, machine vision, and natural biological perception. And so we're applying advanced deep neural network strategies to essentially reverse engineer how the rodent brain perceives by making algorithms and machines that can see the way rodents see. And so this is exciting for students that have a computer science background, mathematics background, but also the experiments themselves are very challenging. And so wet lab type of students that like surgeries and imaging and actually looking at the brain also find these projects exciting.
I hope that you've enjoyed this overview of our neuroscience graduate program here at Baylor College of Medicine and that we've convinced you that this is an amazing place to train in the neurosciences. Lastly, I hope that I'll see your application.